Hi friends, today I am giving a lecture on algorithm for Hamiltonian Cycles Problem in backtracking in design and analysis of algorithms. First of all, before going to this algorithm, this is the given graph. This graph consists of 5 vertices, 1, 2, 3, 4, 5. 5 vertices. The corresponding adjacency matrix is row wise 5 vertices we are taken, column wise 5 vertices we are taken. Okay, so for the 5 vertices, at each and every vertex there are no self loops are there. So that is 1 to 1 there is no self loop is there. Because of that reason we have to write 0. 2 to 2 there is no self loop is there. 2 to 2 that is 0. 3 to 3 0. 4 to 4 0. 5 to 5 0. Okay. At each and every vertex there is no self loop is there. Because of that reason the diagonal elements are 0. Next one, we can take this edge 1 comma 2. 1 and 2 are connected by using edge, then it can be represented by value 1. Okay, so 1 comma 3 they are connected by using edge, so 1 and 3 here the value is 1. Okay, so this means in the given adjacency matrix, suppose the value 1 represents, so the 1 represents the two corresponding vertices are connected by using edge. For example, 2 comma 5. So 2 and 5 vertices are connected by using edge. So that is, this is 2 and this is 5. The corresponding value is 1. Okay, we can take any pair of vertices that are connected by using edge. Its value can be represented by 1. Okay, suppose there is no edge between the pair of vertices, then that value is represented by 0. Okay, so this is the cost adjacency matrix. Okay, so for this graph, this is the cost adjacency matrix. So for this graph, we have to find out all the Hamiltonian cycles present in the given graph that we are discussed in this algorithm. Okay, next, algorithm Hamiltonian of K. So here K is nothing but index of the solution vector. Okay, what is the solution vector? So suppose this graph consists of 5 vertices, so that is n is equal to 5. Okay, so the solution vector is x of 1 to n. So here n is equal to 5, that is x of 1 to 5. Okay, so here one Hamiltonian cycle is, we are starting at vertex 1, then go to vertex 2, then go to vertex 3, then go to vertex 4, then go to vertex 5, then go to vertex 1. This is one Hamiltonian cycle. Hamiltonian cycle. 1, 2, 3, 4, 5, 1. Okay. So this is one Hamiltonian cycle. This is the starting vertex and this is the ending vertex. Starting vertex and ending vertex should be the same. The remaining vertices should be visited exactly once. Okay, there is no repetition of vertices except the starting vertex and ending vertex. So then we can say that it is a Hamiltonian cycle. Okay, so this is the solution vector. X of 1 to n is equal to x of 1 to 5. So that are 1, 2, 3, 4, 5. After 5, it is connected to starting vertex. So this is the Hamiltonian cycle. Algorithm Hamiltonian of K, where K is the index of the solution vector. In the solution vector, one Hamiltonian cycle is present. To access each and every vertex in the Hamiltonian cycle, we have to index. That index is represented by capital K. Okay. Now, this algorithm is used for finding all the Hamiltonian cycles present in the given graph by using the recursion. Okay. Next, this graph can be represented as a adjacency matrix, that is G of 1 to n comma 1 to n. This 1 to n represents the rows that are 1 to 5. This 1 to n represents the columns that are 1 to 5. So this is the given adjacency matrix for this given graph. Okay. All the Hamiltonian cycles begins at node 1. Okay. All the Hamiltonian cycles begins at vertex 1. Okay. So brace begin, repeat until is nothing but do while loop. Okay. So repeat, brace begin. First, the Hamiltonian cycle starts with vertex 1. Okay. Next, generate the next vertices after the vertex 1. So whatever the vertices we have to consider, so that vertices are generated and that can be assigned to x of k. Okay. So that vertices are generated by using the function called next value of k. Okay. So here the first initially starts with the vertex 1. So here algorithm Hamiltonian of k pointing to the first vertex in the given graph. Okay. So after that, what is the next vertex in the Hamiltonian cycle? That can be calculated by using this function next value of k. Okay, this function is used for finding the next vertex that can be assigned to x of k. So whenever next value of k is nothing but, we have to find out the next value of vertex k. Here k points to the index of vertex 1, because every Hamiltonian cycle start with vertex 1. K points to the index of vertex 1. Then we have to find out the next value of k. That means vertex 1 is connected to which vertex in the Hamiltonian cycle. So that vertex value can be calculated by using this function next value of k. This is the calling function. So whenever the function is called, the control can be transferred from calling function to called function. Okay. So this function is used for finding the next vertex in the Hamiltonian cycle after starting vertex. Okay. So algorithm next value of k. Okay. So brace begin, repeat, brace begin. X of k is equal to x of k plus 1 mod n plus 1. So this is the mod function. This function is used for finding the next vertex. Okay. After the starting vertex. So this function is used for finding the next vertex in the Hamiltonian cycle. Okay. Suppose x of k is equal to 0. X of k is equal to some positive value, some value. So here this function returns either 0 value or some positive value. Okay. So if this function returns suppose 0 value, then if x of k is equal to 0, then return nothing. Okay, so this function returns the 0 value. We have to check this condition. If x of k is equal to 0, then return nothing value. Okay, this function returns some non-zero value, that is x of k is equal to some non-zero value, then it can goes to this condition. Okay, if g of x of k minus 1 comma x of k. Okay, so suppose here vertex 1 is k value, and this is next one, this is k plus 1 value. Okay, here x of k returns value 2, for example. So here this is 1, k points to the vertex 1, next value of k points to the k plus 1. Okay, so this returns value 2. So then g of x of k minus 1 comma x of k not equal to 0. That means here k and k, this is k plus 1, now it becomes k and it becomes k minus 1. Okay, because k is incremented from k to k plus 1, now this becomes the k value, it becomes the k minus 1 value. So k and k minus 1 value are connected by using edge or not. Suppose these two are connected by using edge, its value is 1. If these two vertices are not connected by using edge, its value is 0. Okay, so now this is initially k points to the vertex 1, next value of k returns index of 2. So now this is k and this is k plus 1. Now it becomes, this is k value and this is k minus 1 value. These two are connected by using edge or not? Yes, 1 and 2 are connected by using edge. So then g of x of k minus 1 comma x of k is equal to 1. See here we have to check, is there an edge between next value of k and initial value of k. Both are connected by using edge. Okay, so next brace begin. If this condition is true, both are connected by using edge. Brace begin. For j is equal to 1 to k minus 1. Okay, so for example this process is continuous. So then here k value started with the 1. Next, so this is k minus 1 value and this is k value. Okay, so now we have to check for j is equal to 1 to k minus 1. 1 to k minus 1, k value is incremented from 1 to up to 4, that is k minus 1. 1 to k minus 1. If x of j is equal to x of k, then break. Now we have to check any duplications are there. Okay, so this is j value 1 and k value 1. So 1 is equal to 1 if any duplications are there. Okay, there are no duplications are there. So because initially k value 1, k is incremented up to 4. Last one is k minus 1 value. Here there are no duplications are there. 4 is not there 2 times. 3 is not there 2 times. 2 is not there 2 times. And 1 is not there 2 times. For j is equal to 1 to k minus 1, do if x of j is equal to x of k. If any duplications are there, then break. Okay, whenever this condition is true, again the control can be transferred from outside of the entire loop. Okay, if there is no duplications are there, this condition is failed. Okay, now go for next statement. If j is equal to k, now k value is 5 and j value is 5. Up to this point we have to check for any duplications are there. There are no duplications are there. Again k value is incremented from k minus 1 to k value. So now if j value can be incremented from 1 to k. Okay. So now j is equal to k. Previously j is equal to k minus 1. We have to check for 1 to k minus 1. We have to check for any duplications are there. If any duplications are there, then condition is true. It goes to the outside of the loop. If there are no duplications are there, then again we have to check for up to 1 j is equal to k. J value is incremented from this place to this place. Now it is k value. If j is equal to k, then we have to check if k less than n or k is equal to n. What is k value? K value is 5. And what is n value? N value is equal to 5. And g of x of n comma x of 1. X of n is means x of 5 is x of 1. X of 1. 5 and 1. X of n is nothing but x of 5 and x of 1. X of 5 and x of 1 is means x of 5 value is 5, x of 1 value is 1. 5 and 1 are connected by using edge or not? Yes, 5 and 1 are connected by using edge. Here we have to check two conditions, whether k less than n or k is equal to n and g of x of n comma x of 1 not equal to 0. K less than n means, so suppose k value is incremented 1 by 1. So if k less than n, okay, k value is less than n value 5 or k is equal to n. K value is equal to 5 and n value is equal to 5 and g of x of n means x of 5. So that is x of 5 points to vertex 5. X of 1 means x of 1 points to vertex 1. 5 and 1 are connected by using edge. Yes, 5 and 1 are connected by using edge. So this condition is true. K is equal to n, 5 is equal to 5. This condition is true. Here this value is true and this value is true. True and true, that is total is true. Okay. K less than n means this condition is k value 5 and n value 5, 5 less than 5. So this is false. So false or true, that is nothing but true. So then break. So here the control can be transferred from outside of the loop. There are no statements are there. Okay. Again it can returns to the this one. Okay. If x of k is equal to 0, so it is false because x of k contains 5. Okay, so x of k value is 5. 5 is equal to 0. Condition false. Then it can goes to the next statement. Here k value is equal to 5 and n value is equal to 5. Then write x of 1 to n. X of 1 to n means 1, 2, 3, 4, 5. So this is solution vector x of 1 to n. 1 to n means n value 5. X of 1 to 5 is set of 1, 2, 3, 4, 5. Okay. So if k is equal to n, so according to this one, k value 5, n value 5, then write the solution vector x of 1 to 5. Here x of 1 to 5 is nothing but 1, 2, 3, 4, 5. Okay, so this is one Hamiltonian cycle. 5 is connected to 1 in the given graph. Okay, else if k is equal to n is false, then go to the else part, Hamiltonian of k plus 1. Now, so this again this function is called here k is equal to k plus 1. Okay, so the same function can be called again. So then this is a recursive algorithm. Okay, so if the condition is true, then write the solution vector. If the condition is false, again the same function can be called. Okay, so now this is the algorithm for Hamiltonian cycle. This algorithm is used for finding the all Hamiltonian cycle for a given graph in a recursive manner. This algorithm is used for finding the next vertex in the Hamiltonian cycle. Okay, so thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name DIVVELA SRINIVASA. Okay.